Exploring the Solar System, Part 3, the final part for this evening. How we explore the system, not by going out into the solar system, but how we explore the solar system from either here on Earth or at least close to Earth. So I'm going to be talking very briefly about 400 years of telescopes, the first views of the solar system we obtained with telescopes, and what we can get now with the very best telescopes. And then again, I'll be asking the question, what's the next step in terms of the development of telescopes? So we say 400 years because Galileo pointed his telescope towards the skies about 400 years ago. He didn't necessarily invent the telescope. He wasn't necessarily the first person to point a telescope at the night sky, but he was one of the first people to look at the night sky and then record what he saw. And hence we have documentation saying what he saw in the sky. Over the next 400 years, telescopes have changed, mainly because we want telescopes to get larger and larger, not necessarily in terms of magnification, but we want to collect more light. So the lens, or ultimately the mirror of a telescope, over the centuries have been getting larger and larger, so we can see fainter and fainter objects, and also large mirrors, large lenses can see more detail. So it's not about how big they look, it's not about magnification, it's how much detail can we see and how faint an object can we see. So over the centuries, telescopes have grown from the tiny lenses of Galileo, which might only be a few centimeters in size. Then by the time we get into the last century, we're talking about telescopes made with mirrors rather than lenses, and the mirrors now are meters in size rather than centimeters in size. This is the 200-inch or 5-meter, if you prefer, diameter mirror of the Hale telescope in Palomar Mountain in California. That was the largest telescope in the world when I was born. It was also the largest telescope in the world for most of my childhood, all of my childhood. It was also the largest telescope in the world for quite a bit of my adult life. So for me, that is my go-to telescope when I think of the largest telescope in the world. But of course, now we have a different breed of telescopes. We have telescopes which aren't restrained to the surface of the Earth. We can put telescopes in space, such as the Hubble Space Telescope, or most recently, the James Webb Space Telescope. So in addition to developments by lifting telescopes above the atmosphere, which means you get away with not having a really turbulent atmosphere that you have to look through, which distorts your images. If you get above the atmosphere, you get nice, clear views of whatever the object is you're interested in. In addition to space telescopes, we're also building on the ground telescopes with ever bigger mirrors. Remember, we've gone from centimeter size to meter-sized telescopes. Well, it won't be too many years before we have a telescope that has a mirror, or a set of mirrors, 40 meters in diameter. And I'm sure you can't see, but that little speck there is a couple of people. That gives you an idea of just how large telescopes are becoming. And this one will be online in only a few years' time. So let's remind ourselves what Galileo did for us. Galileo looked at the night sky. He looked at a number of different things, including Jupiter. And when he looked at Jupiter, he said, well, our own eyes show us 4 stars which wander around Jupiter, as does the moon around the Earth. This was a pivotal observation because he determined, if we blow up some of his sketchings here, he determined that this bright object was Jupiter, and it seems to be always accompanied by these 4 little dots. Even when Jupiter moved through the sky and was seen against a backdrop of different stars, these little dots always seemed to go with it. Not only that, but if you watched these dots night after night, all of these dots appear to be one side of Jupiter or the other side of Jupiter. It's as if all of these dots seemed to be orbiting around Jupiter. Everything he observed was consistent with the fact that these dots are little moons of Jupiter. So here he had effectively proof not everything orbits the Earth. The Earth is not the center of the universe. Some things appear to want to go around Jupiter, and they definitely don't go around the Earth. So the Earth is not the center of the universe. So definitely a paradigm shift. And ultimately, Copernicus comes up with a model which says the sun is the center of the solar system, not the Earth, and all the planets are moving around the sun. So a very important observation back in the early 1600s. When Galileo turned his telescope on Saturn, well, he was rather confused. The first sight of Saturn was 3 round stars, the one in the middle larger than the other 2. So that was his view of Saturn. What's going on? Is Saturn actually 3 objects? Is it an object with ears? What exactly is it that we are looking at? Part of the problem was his telescope was imperfect. Not surprisingly, the very early optics were not perfect, nothing like the quality that we can produce today. And so there were distortions in his image that he couldn't quite consolidate with his understanding of what it is he was looking at. If we think about what other people have seen, that was Galileo 1610, in the next few decades, lots of people turned their telescopes on Saturn, and they all disagreed as to what it was they were looking at. Are we looking at 3 objects? Are we looking at a planet with handles on either side? Has it got ears? Are we looking at something with a couple of holes? All sorts of ideas of what it is, based on the fact that the telescopes were imperfect, and in a sense, people were guessing what it is they thought they were looking at. Eventually, on improvements of telescopes and a little bit of thought, it was realized, well, actually, what Saturn is a sphere with a ring system around it. This was revolutionary. There's no other known object in the sky, but now they seem to say, well, that's what the telescope is telling us. Saturn appears to be a globe, just like the moon, just like the Earth, but it has a ring of something around it. Of course, we know that is precisely what Saturn is. Here's a much more recent image from the Hubble Space Telescope. Basically, Huygens in 1659 got it nailed. He knew exactly what it was, but it did take a few decades to figure out that that's what they were actually looking at. When it comes to our friend Mars there, here's Schiaparelli, who made some notes in his notebook of what he thought he was seeing on the surface of Mars. I love the fact that his notebook is a little bit scrappy. It has an extra half page put into it, which is held in place by some stamps. I mean, this is a great scientist. He wants to get the record right. He doesn't want to waste a stamp, so he cuts the stamp in 2 and then sticks this little note in on top. And here's his drawing of Mars. And just to make it a little clearer, he's then expanded on the right-hand side a slightly larger version of what it was he was looking at. Schiaparelli looked at Mars through his telescope, and he basically said there's lots of markings. Some parts are dark, some parts are light. We can see that from Mars above us here. But he was also convinced that he was looking at lots of lines, lots of linear features. He called them canali, which were unfortunately mistranslated as canals. He meant channels, and they are channels in that sense, but canals has an implication, a connotation, that they are man-made. So Schiaparelli basically said, I think I can see these features on Mars. There's some dark patches, there's some light patches. There appears to be a polar ice cap that we can see there on Mars, but Mars appears to be crisscrossed with these canali, or channels, or ultimately canals. Schiaparelli said, I can see them. Other people said, yeah, I can see them as well. Some people said, I'm not altogether convinced I can see the same things that you see. But one person in particular, Lowell, the American in the late 1800s, said, yeah, these are definitely canals. It is fairly obvious that these are irrigation canals. They link the water in the ice caps to the arid desert in the equator, and it's clear that a civilization exists on Mars, and these are an irrigation system to keep these Martians alive. Lowell was convinced that this was the case. The New York Times basically says, Professor Percival Lowell, recognized as the greatest authority on the subject. I don't know who says that. Maybe Lowell says he's the greatest authority on the subject. There can be no doubt that living beings inhabit our neighbor world. He was absolutely 100% convinced that that was the case. But the more people looked at Mars, the more people said, well, I think I might be able to see these canals, but I'm not altogether convinced they're there. Lowell and others were using very large telescopes here, a very large lens at the front end and a tiny little eyepiece at this end. There's Lowell sitting at his telescope. It is thought that the most likely explanation is when you collect an awful lot of light and concentrate it down to a small eyepiece and then look into this eyepiece, what is it you see when you go to the optician and they shine a bright light in your eye? You see the blood vessels on the back of your eye. You see lines. And maybe Lowell was actually seeing, and Schiaparelli were actually seeing what they thought were linear features, but actually it was just artifacts of the fact that they had a very bright spot of light coming into their eye. And basically they were just looking at not their eyelashes, but perhaps blood vessels on the back of their eye. And they were misinterpreting what they were seeing as canals on Mars. It wasn't too long before people like Schiaparelli said, I can see straight lines, but everybody else was saying, well, no, I can see dark features, I can see light features, there might be craters there might be volcanoes there, there's definitely variations of brightness, but I don't see these straight lines that you say are there. So eventually the idea of Mars covered in canals was replaced with the modern idea that Mars is very interesting and has lots of dark and light patches, but as far as we can tell, no sign of these canals that were reported in the late 1800s and early 1900s. Amateurs, just like professionals, want to get telescopes with the largest aperture possible. They want the largest lenses or the largest mirrors in order to collect as much light, to see the faintest objects, to see detail in all of the objects they're looking at. Telescopes come in all shapes and sizes. So for instance, any telescope that uses a lens at the front end to collect the light is usually called a refractor. Any telescope that uses a mirror at the back end to collect the light, they're normally called reflectors. There are a certain type of telescope that use a combination of lenses and mirrors. And they end up getting called rather awkwardly catadioptrics, or everybody just calls them cats. So there are various types of telescopes that amateurs are interested in, and depending on how deep your pockets are, you will always lust after the next largest telescope that you can possibly afford, because bigger aperture means see more stuff that's out there. Bear in mind that some amateur telescopes are extremely sophisticated and, unfortunately, very big and very expensive. And when I say big, you probably can't judge how big that particular telescope is until I put a person next to it, and then you realize these things are huge, and they weigh hundreds of kilograms, and they cost tens of thousands of pounds. Not many amateurs can afford them, but they are, strictly speaking, available. They are on the market and are being made around the world, and amateurs can buy extremely sophisticated equipment if they want to explore the heavens in the way they want to. If we think about the sizes of not telescopes like Galileo's, but if we look at telescope sizes over the last 100 years, this is a little infographic which gives you the relative size of mirrors of various telescopes. These are all to scale, and the scale is indicated by the tennis court down here, or the basketball court down here. There is actually a human there. You can see a human is a few pixels high on this scale. The largest telescope at the world at the moment is called the Gran Telescopio Canarias. It's that one at the top, and it's sitting on the Canary Islands. Notice that really big mirrors aren't made out of one piece of glass covered in metal. They're often made of lots of smaller pieces, hexagons, which are then pieced together to make one larger mirror. It makes it more economical, it makes it easier to manufacture. Space telescopes tend to be smaller. We would like to put a really big telescope into space above the Earth's atmosphere, but it's really difficult to get them on top of a rocket and get them up there, so space telescopes tend to be smaller. The James Webb Space Telescope, for instance, is rather smaller than the largest land-based telescope that we have at the moment. And there's the Hubble Space Telescope, a mere 2.5 meters or so in diameter. But look on the right-hand side. These are the telescopes that will be coming along before too long. This is the European extremely large telescope. Well, and that's a pretty boring name for a really big telescope, but that's what they decided to call it, the European Extremely Large Telescope, made of hundreds of smaller hexagonal segments in order to make an overall mirror of approximately 39 meters in diameter. So you can see it's huge compared to even a basketball court. The amount of light this mirror is going to be able to collect when it's operational in a few years is going to be absolutely phenomenal. People have thought about, could we make anything bigger than that? This one is under construction in Chile. People have thought, well, 39 meters. Could we ever make anything bigger than that? Well, this circle in the background that's sort of a mottled grey, some people have said, could we ever build a mirror that big? Not 39 meters in diameter, but 100 meters in diameter. And there's no money to build one, but they have come up with a name. It needs to be bigger than the ELT, the Extremely Large Telescope. They've already had very large and extremely large. What do you go with next? A mirror that big, they said, let's call it the OWL, the OWL. Is that because owls have large eyes? No, it's because OWL would stand for the Overwhelmingly Large Telescope. But no, they haven't got funding for that, but maybe in years to come, people might think about. But it's going to be exciting enough just to have the Extremely Large Telescope. So yes, when I was a lad, this was the biggest thing in the world, with a mirror at the bottom here that was 5 meters in diameter, half of the size of the world's largest telescope today. Where are these telescopes sited? Well, the best place to put a telescope, remember you're looking through the Earth's atmosphere, so you want to minimize how much atmosphere you have to look through because the atmosphere is usually turbulent, so you stick your telescope on mountains. So the best place to put telescopes are either the Hawaiian volcanoes, very high, very close to the top of the atmosphere, or the Canary Islands, almost as high, again on top of a volcano, like on top of Mount Teide or on top of La Palma, or you put them in the high desert of the Atacama. That's very high, very low water content, very dry, arid, and again, the elevation means you're above most of the atmosphere. You can get an idea of what it looks like if we have a look at an observatory there. There's an observatory on a mountain top as photographed by another observatory on the next mountain. So it looks a bit hazy in the background, but bear in mind, most of the atmosphere is below you, and you're looking through a minimal amount of atmosphere above. If that's still too much for you, what can you do? Well, you can put your telescope in the back of a 747. And yes, they did actually do this. This is the Stratospheric Observatory for Infrared Astronomy. They put a telescope in the back of a 747. It was operated by Germany and NASA. And basically, you fly your 747 at 10,000 meters or 12,000 meters or whatever. And again, you're above most of the atmosphere. There's still some air above you, but most of the influence of the atmosphere is below you. Some light will be absorbed. Some light will still be turbulent, distorted by the turbulence. But that's better than being at ground level. But of course, better still is you put it completely above the atmosphere and you put it into space. Hence the Hubble Space Telescope and the new generation of space telescopes, such as the James Webb Space Telescope, launched on Christmas Day 2021. It's a very large mirror, but in order to get it on top of a rocket, they had to design it in the lab there and then fold it up like a piece of origami, so that it was eventually small enough that they could put it on top of a rocket and then send it above the Earth's atmosphere. What's the difference between using the Hubble Space Telescope, which looks at visible light, and using the James Webb Space Telescope, which works in the infrared part of the spectrum? If we have a look at Jupiter, the two telescopes have very similar levels of resolution. The amount of detail we can see is very similar. We see the great red spot here, a storm system that's been raging. Even Galileo knew about this storm system, so it's been going for 400 years. The colors here indicate that we've probably got some sulfur, probably some phosphorus, probably some other molecules mixed in there. Notice that James Webb sees things a little differently. If you look in the infrared, you're not getting the same information as if you look in the visible. You're effectively looking at how heat is being generated by the planet. It may look like there's a little bit of distortion at the top and the bottom. No, that's not flare, it's not distortion. This is genuine light at the north and south poles because we're seeing the aurora borealis and the aurora australis on another planet. Particles are coming from the sun, getting caught by Jupiter's magnetic field and funneling into these areas, making the atmosphere glow in these particular colors. If we think about what Saturn looks like, and is it different between the Hubble and the James Webb? Here's the familiar view of Saturn from the Hubble Space Telescope. That's the sort of view we get, not as crisp, but that's the sort of view we get if we look through a small amateur telescope. But when we look with the James Webb, because we're looking at infrared, we see things rather differently. The actual planet itself, depending on which wavelength of infrared light we're using, the planet absorbs a lot of infrared light from the sun, so looks rather dark. But the rings are made up of huge numbers of tiny icy particles which reflect infrared light really efficiently. And hence the rings look really bright, even though the planet looks rather dull. Not quite what you'd expect by looking in the visible part of the spectrum. The same is true when we look at other planets. So Uranus also has rings. They're not as bright as Saturn's rings, but if we look at with the James Webb Space Telescope, we see the rings look a lot brighter because, again, the icy particles in these rings are reflecting infrared light quite efficiently. In this case, we actually see some detail on the surface of Uranus. There seems to be a storm system developing here. Rather oddly, we can actually see more detail on Uranus from these telescopes than we could when we sent Voyager to actually go and see what's going on there. That's because Voyager went past Uranus in only a few hours. Didn't go into orbit, it was flying past Uranus on its way to Neptune. So it only spent a few hours going past the planet. And it just so happened nothing interesting was happening on the planet in the hours it spent going by. But on Earth, we can train our telescopes on the planets, and at our leisure, we can watch them night after night, or week after week, or month after month, and it just so happened we've caught a storm system. So things are happening on Uranus that we weren't aware of simply by sending spacecraft. Spacecraft are great, telescopes are great. Basically, they give you different levels of information. When we look at Neptune, it's a similar story. Neptune also has rings. In this case, it looks very odd because this, which you might assume is a very bright star that happens to be in the background, no, this is actually a tiny moon of Neptune. And yet that moon seems to be so bright it's making Neptune look dark by comparison with this really bright moon. Why should that be? Again, it's because we're dealing with infrared light. Infrared is being absorbed by Neptune, but this particular moon, called Triton, has a surface of solid nitrogen, which reflects infrared light very efficiently. So even though it's a rather small moon, it actually looks really bright when we look at it in infrared. So again, if we look at the planets with one telescope or two telescopes at different wavelengths, visible wavelengths, infrared wavelengths, we get complementary information, which gives us more information about the nature of the planets that we're looking at. What's next in store? We've got space telescopes, we've got big telescopes coming on the ground. Well, we actually have another telescope which is coming online almost as we speak. It's virtually finished. I've said it's under construction, but actually they've finished construction and it's almost ready to go. This is a telescope which goes by the rather horrible name of the Large Synoptic Survey Telescope. That's a rather awkward mouthful. It's basically a survey telescope which is not going to look for particular objects. It is going to scan the sky and basically map everything that it can see. It's going to be mapping billions of stars and billions of galaxies over the next few years, and we're going to use that data to tell us where should we be pointing the other telescopes, what's out there. It's going to find new objects in the solar system. It's going to find new stars. It's going to find new galaxies. The camera in that telescope is huge. That's the size of the camera compared to a standard human standing next to it. And this survey is going to operate for the next 10 years or so. They're calling it the Legacy Survey of Space and Time. And it's going to be mapping the sky over Chile night after night after night to see what's up there, what's changing, what's moving, what is changing color, what is changing brightness, has a supernova gone off, have we found a new asteroid heading towards Earth? And surveys like that will ultimately find what's out there, and every once in a while they say, that looks really interesting, and they'll tell the really big telescopes to go take a closer look. The European Extremely Large Telescope, hopefully operational in another couple of years, a reminder that there's a couple of people standing next to it, there's a couple of people standing on the gantry next to it. The mirror, 39 meters in diameter, is going to be able to collect even the faintest wisps of light coming from not only dark objects in the solar system, but also stars in the distant Milky Way and galaxies far, far away. So again, if you want to know more about the telescopes that exist now, or the telescopes that will be coming online very soon, go visit these web pages and you'll find lots more information. Thank you all very much.